Tracy wants to make a cylindrical model. The height of the cylindrical model, h of v, in inches, is modeled by this equation, where v is the volume of the cylindrical model in cubic inches. So h of v equals 2.69 times the cubed root of v. We want to know what is the average rate of change of the model's height when its volume changes from 512 cubic inches to 1,000 cubic inches. Again, still going to use Desmos on this problem, but I do want to remind you that when we're working with the average rate of change is slope. And the formula for slope is y sub 2, got to be able to see what I'm writing, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And I'm going to pull my iPad back up here in a moment, but the average rate of change is slope, something important to write down. And by the way, when we type this back into Desmos, I'm going to type in 2.69 times the cubed root of x. So we come back over here to Desmos, and typing it in, I want to show you something on the screen here. So it's 2.69, the cubed root. We've talked about it before, but we go to functions, and I'm probably already on it. No, I'm not. And we're going to then, as I scoot this down, go to miscellaneous, that last column, and then here's our cubed root button. And so when we go back up here, then we can type that 3 into the check mark part of the radical. And then again, instead of typing v, I'm going to type in x. So there's the picture, which doesn't really help me. But what is going to help me is if I go to the gear and convert this equation to a table. Now, we were given very specific values. We want to find the average rate of change from 512. So the nice thing is we can type that into the table, and we see that our value is going to be 21.52. Got to be able to see it. We can do the same thing with 1,000. We can type in 1,000, and we see that that value is 26.9. And we've got everything on Desmos that we need now. Here's x1, here's y1, here's x2 and y2. 26.9 minus 21.52, filling into this formula, divided by 1,000 minus 512. That's what we're looking for. But again, when we go down here to this second screen here, 26, oh, I didn't even need to do that. I'm going to put parentheses in, but 26.9 minus 21.52 divided by 1,000 minus 512. And see, we get 0.011 for our answer there. If we go back in here, the only answer where I see a 0.011 is here. The model's height increases by approximately 0.011 inch for every 1 cubic inch increase in its volume.